In model theory, Tarski's exponential function problem asks whether the theory of the real numbers together with the exponential function is decidable. Tarski had previously shown that the theory of the real numbers is decidable. The problem: the ordered real field R is a structure over the language of ordered rings law equals, with the usual interpretation given to each symbol. It was proved by Tarski that the theory of the real field Th is decidable. That is, given any law sentence phi, there is an effective procedure for determining whether. He then asked whether this was still the case if one added a unary function exp to the language that was interpreted as the exponential function on R, to get the structure rec. Conditional and equivalent results. The problem can be reduced to finding an effective procedure for determining whether any given exponential polynomial in n variables and with coefficients in Z has a solution in Rn. McIntyre and Wilkie showed that Shanuel's conjecture implies such a procedure exists, and hence gave a conditional solution to Tarski's problem. Shanuel's conjecture deals with all complex numbers, so would be expected to be a stronger result than the decidability of rec, and indeed, McIntyre and Wilkie proved that only a real version of Shanuel's conjecture is required to imply the decidability of this theory. Even the real version of Shanuel's conjecture is not a necessary condition for the decidability of the theory. In their paper, McIntyre and Wilkie showed that an equivalent result to the decidability of Th is what they dubbed the weak Shanuel's conjecture. This conjecture states that there is an effective procedure that, given n1 exponential polynomials in n variables with integer coefficients f1, fn, g, produces an integer eta1 that depends on n, f1, fn, g, and such that if alpha Rn is a non-singular solution of the system, then either g equals 0 or g greater than eta minus 1. Workaround. Recently there are attempts at handling the theory of the real numbers with functions such as exp. sin by relaxing decidability to the weaker notion of quasi-decidability. A theory is quasi-decidable if there is a procedure that decides satisfiability, but that may run forever for inputs that are not robust in a certain, well-defined sense. Such a procedure exists for systems of n equations in n variables.